This is a devlog about what had happened between the episodes. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. As you see, lots of classes are opened and there are tons of things that has changed between the previous episode and this episode. I want to walk you through everything because honestly they are nothing new but time consuming related to the coding and API itself. I was getting ready to write the rest of dispersion stack payload. Then I noticed that, you know what? I have a record related to fluids. I have a record related to gas. Then I have a class or a record. I'm not sure which one I should use about heat component. For pressure, I was using a simple double. So I made the decision that, you know what? For pressure, I need that component too. And then I made the decision that I don't like the concept of these components being records, so I converted them to classes and lots of things happened. Let's take a look at the biggest change, and that is writing my own single fluid storage. And as you see, I'm extending from the Fabric API's single fluid storage. As much as I know, in Java you don't have any way of injecting your code on top of the base API that would work before the build time. I mean, when I'm coding, I want to see something from single fluid storage. If I use mixin, it means that I could use that code in runtime, not at build time. Any sort of annotation usage will work at build time. So if I want to be able to, for example, see the heat component on a single fluid storage, and I would want to use Fabric API's single fluid storage, I won't be able to do that. Because of that, I wrote my class with exactly the same name, but extending from the original one, adding my heat component and pressure component to it. I have some setters and getters for both the heat component and pressure component. Those are simple. I have two methods to set the fluid and get the fluid payload. As you see, I'm returning a fluid component. And as you see, it was a record, but it is converted to class. We will talk about that in a few minutes. However, the main important thing is here. Because I'm extending from single fluid storage, I can utilize the read and write value provided inside the base class and serialize and deserialize my own components after calling the super, because the super is actually writing the fluid amount and fluid variant. Now, knowing this, when I look at the read value, for example, you see that it is reading value from single variant storage, and all it's doing, it's taking a look at that value and reading the variant and amount, or it's writing the variant or amount. I was doing the same thing, didn't I? So the changes that I had done into the serializer, I'm not writing the variables again. So all I'm doing here, I'm making sure that I'm single fluid storage, and as you see, it is my fluid storage, and I'm calling the write or read value here. And if I'm not the type of single fluid storage, I'm throwing an argument exception. Now, in case of heat, energy, and pressure, I was debating on sticking to single storages or letting the user to have different type of storage and using the transfer API in these situations. However, I made the decision that, you know what, I will stick to the single fluid storage. If anyone ever needs an advanced storage that will contain multiple types of variants inside a single storage, then be my guest. You can override this record or use this record as your base and write your own on top of it and utilize that one. However, if you want multiple variants of something inside your block, why not use a list of single storages? That gives you much more flexibility, and at the same time, it will keep things simple. And that is why you see that Fabric API is not really bothering himself to write a mixture of different variants inside a storage. Yes, they gave you the ability, but they are not really diving into that. A combined storage is actually the thing that we are talking about. And as you see, it is there in Fabric API. However, most of the time, a list of single storages will do the same thing with giving you the ability to change the order of things in the list and lots of other things there. So that is our serializer now, and it happened in every serializer. Basically, in every serializer, instead of writing the amount and the values separately. If I have a storage of a variant, I just call the read and write on top of that one. The only exception is the energy, and I don't see it open right now, but honestly, the energy is the only exception, and I had to write the amount and read the amount manually. Again, that's a single line of code, so we don't have a variant there to be worried about. After adding this single fluid storage and my serializer, I came back to my block entity for abstract base, because in here, I made sure that when I'm writing or reading, actually here is writing and the other one is reading, the information from the block entity on an item, I need to handle things. For example, I want to get a list, and this list contains all the fluid components. Don't forget, it's a fluid block entity, so I'm sure that this block entity has a fluid storage and actually a list of fluid storages. And because of that, I'm adding a list of heat component and list of pressure component. Each fluid storage has its own heat and pressure, although you can ignore them, but if you want to utilize them, they are there. By default, the heat is the room temperature and the pressure is the atmosphere pressure. So they are physically accurate if you want to use them. The heat unit is actually Kelvin and the pressure unit is Pascal. Anyway, after writing these to different lists, as you see, I put them on data components, and then by default, the system will take these data components and put them on the item using the builder, because you see, I'm adding them one after another to the builder. After that, when I put the item back into the world as the block, I want to retrieve those values and regenerate and repopulate the storages. So I read the lists and then I check if different lists has the same size, because they should. Finally, I loop through one of them and I populate the rest. Anyway, that is our apply implicit components and collect implicit component. These two happen in the base fluid BE. Of course, for the gas BE, I have to do the same thing. I'm not sure if I have that open right now, abstract base gas BE. And if I open that, you see that the same concept is happening here, having heat and pressure list, because my single gas storage now has the heat as the component and pressure there. Of course, the same concept for reading and writing is happening here too. So let's close the ones that I talked about and the base BE. Then we can move forward. When I was doing this whole process, I noticed that my fluid stack is actually not what I want, because it's a record. I can't change it on the fly. For example, if I want to change the amount, I have to regenerate a new record. That is okay as long as you want to send a packet on the network or serialize and deserialize the data back and forth. However, if for whatever reason you make the decision that, you know what, I want to have a single component related to fluids that only has the amount and variant and nothing else, using a record is not the proper way of doing it. Because, for example, let's say that I have a machine. It shouldn't have a storage, but I want to be able to store the data for a fluid variant and amount there without utilizing any storage system. Then I don't have a way to do that. Finally, made the decision that gas, pressure, heat, and fluid shouldn't be records. And they became fluid component, gas component, heat component, and pressure component. All of them are simple classes that implement the payload. Because of that, I can send them back and forth in the network. However, you should be careful, because when you want to send things back and forth on the network, they should be immutable. Class is mutable. Anyway, that's the use case, and you should be careful about what you are doing with that use case. But I gave myself the ability to use the same structure in whatever shape or form I want. Basically, all I did was add the properties here. I had the ID, I had the empty and codec and packet codec and the list and everything. I gave myself a constructor, some setters and getters, and then I have these methods to check if they are empty, if they are matching each other with another component, or I can get myself a new component with a new amount, although this is obsolete now. I can test for recipes, and I can make a new one based on a fluid storage. Now, the same concept happens for gas component. As you see, it's the same thing, just different things. For example, gas variant instead of fluid variant. The same concept is there. Now, you may notice that the gas component is not as complete as fluid component. For example, I don't have any method to test for recipes and things like that. The reason is that the gas component is still under development. I need few more hours to finish this, but it's almost complete. After the gas component and the pressure component, as you see, same things, just a little bit difference here and there. I started working on the other aspects. For example, changing the fluid from the record to class had minimal aspect of inflecting anything. For example, getting a fluid was previously just a method call with the name of fluid and then parentheses. However, now it became get fluid and things like that. But for fluid stack, I added two more methods that accept a list of fluid component or a list of variant and a list of amount and return the list of stack from there. Now, I started adding accurate physical aspects of different things. For example, I have this gases class, and here I created some base gases that we have in nature. For example, oxygen or nitrogen or argon or neon, xenon, and anything else with accurate physical numbers. For example, the molar mass, it's a chemistry thing, or thermal capacity and thermal conductivity. Although I'm not using them or utilizing them inside my own classes, but they are there if someone wants to write an accurate, physically correct, mathematically calculated dispersion, or I don't know, maybe transferring things around or do anything related to thermodynamic calculations. The values are there for them. Then I went into the gas variant, and as you see, I just added and removed few things here because honestly, I don't have this air here anymore. I moved the air into the gases, and as you may notice, I did add few methods that I implement them inside the variant IMPL related to physical and aerodynamic and gas methods. For example, this PV equals nRT is a physical formula, and I'm implementing them. However, as I said, I'm not utilizing or using any part of these accurate physical calculations myself in my mod, even in my library. They're just there. After that, I utilized the gas component. You notice that I have this gas stack payload, and it's still a record. Side by side with this gas stack payload, I have a gas component. And as you see, a gas component is exactly the same thing. It's an amount and a variant, and gas stack payload is just a variant and amount. So it's still a work in progress. I will delete and nuke this guy. I will make the other one a payload. Things like that will happen between the episodes from now on, but I'm not going to talk about them for too long. But the moment I nuke this guy and utilize this guy as the payload, of course, I need to tweak things here and there around a little bit. Again, I have gas components related to different types of gases, and as you see, these are just utilizing different capacities. And by the way, gas constants are exactly the same numbering system as the fluid constants. However, we don't have ingot or nugget or bubble of gas, so I did remove them, and I changed the bucket to be a unit of gas, and I just added few constants here so that if anyone wants a unit of air, being it 81,000 liters worth of air, then they have that ability there. Heat component, as I talked about it, is the component related to heat. Similar concept between the fluid, gas, heat, and pressure, because you see that I have a pressure component here. Then I have the heat component list that is again using the heat component here. I have a heat helper that is spreading the heat between different objects and from a central block toward the storages around itself. The only thing that I changed in the devlog is addition of this line here. Basically, if the current block and the adjacent block that I want to transfer heat around have the same heat, I have nothing to do, just return or continue toward the next ones. Then we have the component pressure list that is utilizing the class now instead of the record. Item stack list. Here I added a class that accepts a list of item stack and returns the item stack list. Then we have these API classes. Right now the dispersion API is empty because, well, we are working on dispersion API. However, I moved things around from the shared library and many different places into these API classes. Basically, each API class will have two different components at the very least. One is a single component and one is a list of the previous one. Now, for energy, for example, we only have the amount as the value that we want to track. Because of that, we have this data component type of long that says the component for the energy. But then I have this list of longs that contains a list of energy amounts. And they are data component lists. I'm registering them. I'm defining them in the static block. And the way we are utilizing this init without being a real mod in a library is really simple. It's similar almost to any other mod inside our entry points, inside the main. As you notice, I'm not only going for the class name, but I use a colon and I call the method name here. This means that I don't need to extend my API classes from mod initializers or anything else. I'm just saying that, hey, this is an entry point inside this library. Use it whenever my mods or libraries are loading inside the initialization phase. Now, the fluid, the gas, and the heat and the pressure, these are almost identical because as you see, I have two components. I'm registering them, I'm defining them, and then I'm registering them. I have two components, I'm defining them, I'm registering them. Again, two components, same deal. However, as you know, in some of them, like the heat API or gas API, at any point I may need to change things here and there. For example, the gas needs its own registry entry into the system. The heat has this item that needs to be handled. Pressure again needs this item to be handled. We will have something like that inside dispersion. But shared API is the only class that is not complete yet. Let me close the rest and talk about this one. Now, as you may have known, if you looked ever into my library or the process of generating this library, you know that I have lots of payloads. And then recently I added lots of lists of these payloads. And for each one of them, being the payload or the list of payload, I want to have a data component type here under these two. For example, right now I have a coordinate and active mode. Then I will have a list of coordinates, a list of active modes, and so on and so forth for different use case examples. Also, you may notice that for each one of these payloads, I was using a namespace as a single text here. I moved it inside the API classes as IDs, and here I'm utilizing those IDs. That is everything that happened between the episodes. It may look like a very fast forward talk. However, it took me near 2 or 3 days from morning to the night to handle everything, because it's not just writing the code, it's about thinking about the process and figuring how different things should sit together and work together and talk together so that your API would be a nice API. And every now and then I had to move things back and forth until I'm happy with the final design. Anyway, in the next video, I will come back and finish my dispersion stack payload. Have fun, everyone. Bye.